On. All right, I am Riza Ana Alforja, FMDS Research Support Staff, and I will be your host this morning. Welcome to the first episode in our discussion series entitled Usapang Mapa at Kapaligiran, a discussion series on urban planning, environmental management, and sustainability. This morning, our esteemed speaker will be discussing forest carbon accounting using remote sensing. This insightful lecture is brought to you by the UPOU Faculty of Management and Development Studies and the UPLB Interdisciplinary Studies Center for Integrated Natural Resources and Environment Management, or UPLB INREM. This discussion is part of our ongoing series designed to deepen our understanding of mapping technologies and their critical role in addressing some of today's most pressing environmental challenges. This is also part of the intersection of our public service, research and instruction trusts, which we call community inclusivity, digital transformation, and acceleration towards sustainability, or CDAS. We are live on site here at the UPOU Audio Visual Room. We are also streaming live via the UPOU Network's website, the UPOU Facebook page, and the UPOU YouTube channel. This event aligns with various sustainable development goals, namely Industry, Innovation, and Infrastructure, or SDG 9, Sustainable Cities and Communities, or SDG 11, and Climate Action, SDG 13. Now, to formally welcome everyone to this event, let me call on our Dean, Professor Joanne V. Serrano.
Thank you, Raisa. Isang maalab at mapagpalayang araw sa ating lahat. Bago ang lahat, gusto ko pong i-acknowledge and thank ang ating esteemed speaker, Dr. Arnan Arasa, who is joining us today on site. Thank you very much for sa pagpapaunlak sa aming imbitasyon. It is my honor to welcome everyone to this Let's Talk It Over series. This event marks the first of a three-part discussion series centered on the vital principles and components of Geographic Information Systems, or GIS. The Let's Talk It Over, or LTIO series, has long been a pillar for knowledge dissemination and community engagement of FMDS. And this initiative exemplifies the FMDS, or the Faculty of Management and Development Studies, unwavering commitment to making education accessible and inclusive for all. As an interdisciplinary and transdisciplinary hub of learning that spans fields like health, environment, management, and development, FMDS addresses a broad range of policy and program concerns. These encompass crucial areas such as environment and natural resources management, land valuation, research and development, nursing, international health, social work, public management, entrepreneurship, and sustainability studies. And through the LTIO, FMDS is able to maximize the affordances of technology to bridge the gap between knowledge and those who seek it. And this hybrid seminar is a testament to our commitment to inclusivity as we bring together both our physical and virtual communities to engage in meaningful conversations that transcend geographical boundaries. The United Nations Sustainable Development Goals serve as our source of inspiration, and through initiatives like LTIO, we aim to empower both the general public and our FMDS students to contribute meaningfully to these global initiatives and objectives. Today's seminar, which focuses on Usapang Mapa at Kapaligiran, which is a discussion series on urban planning, environmental management, and sustainability, aligns seamlessly with key SDGs, particularly those focused on sustainable cities and communities, climate action, and life on land. And as we explore the role of GIS in urban planning, environmental management, sustainability, I encourage everyone to engage, share perspectives, and take away actionable insights that can contribute to meaningful change in our communities and beyond. Before I end my welcome message, I'd like to encourage each of you to engage with our with our speaker. And we'll also like to invite everyone to engage in our public service initiatives, which is focused on SIDAS, mentioned by our MC earlier. We have ongoing initiatives related to the topics discussed, and we encourage you to get involved through volunteering, research collaborations, or advocacy work. Once again, welcome to the LTIO Series Hybrid Seminar. Let's engage, learn, and inspire each other as we explore sustainable solutions for our communities. Maraming salamat po.
All right, thank you very much, Dean Joanne, for this welcoming message, which shows the significance of the UPOU FMDS LTIO in bringing this kind of discussion to the next level of advocacy or campaign and policies as well. Before we begin our lecture this morning, may we kindly remind our participants on site as well as those streaming online that you may already begin preparing your questions while listening to the presentation. For our on-site participants, we will be giving you a piece of paper where you can write your questions. You may give this paper to any one of our facilitators wearing green at the back, or you can also ask your question personally during the open forum. It's my pleasure to introduce to you our speaker this morning. He was born and raised in Bay Laguna in family of teachers and earned a certificate in forestry and a BS in forestry from the University of the Philippines, Los Baños or UPLB between 2003 and 2009. He later pursued his master's and PhD at Wageningen University and Research, a world-renowned institution for agriculture, forestry, and environmental science. Before embarking on his graduate studies, he worked as a remote sensing and geographic information system consultant on several environmental projects in the Philippines. These projects were pioneering efforts in integrated ecosystem management and ecosystem accounting involving collaboration with local and national governments as well as international experts. Currently, he is conducting postdoctoral research at Wageningen University and Research. And in addition to his research, he has contributed to updating the Philippine River Basin Master Plans in collaboration with the College of Forestry and Natural Resources, UPLB. He is also involved in advancing climate farming and digital agriculture services with the Leeds Agri. He is the first Filipino to receive the prestigious Intergovernmental Panel on Climate Change, or IPCC, Research Award for Young Scientists and has been a two-time Balik Scientist under the Reinvest2 project of UPLB INREM and DOST Picard. Let us all give Dr. Arnan B. Aranza a warm round of applause.
That been invited as the first speaker um, of this activity. Before I start, I'd like to go acknowledge the presence of Dean Joanne Serrano. Good morning po, ma'am. Dr. Asa Sahise, the project leader of Reinvest2 project of UPLB INREM. Everyone here, friends, familiar faces, colleagues at INREM, also of course the online participants, good morning. So I'll be talking about forest carbon accounting based on remote sensing. hopefully I can finish the presentation on time. But we'll see. Uh, we have a lot of things to. I have a lot of things to talk about. We'll start with with a short research bio, and also I'd like to share with you my activities in the BSP program. So I also, of course, give you context first about forest carbon emissions and time, and also in relation to climate change. Talk about remote sensing and how it's the go-to tool to map biomass and carbon. Talk about spatially explicit carbon pools, so not just the above ground component, but also the below ground component, the soil, and also some minor carbon pools like deadwood and litter. Talk about carbon accounting scales, very important. Could be national, subnational, could be a reforestation project. Carbon changes and fluxes mapping. So it's quite the state of the art now in terms of remote sensing application to map the changes itself, not just static or baseline maps. Very important, the UNFCCC carbon accounting framework and the SIA framework, two of the biggest frameworks for carbon accounting. Number 8, uncertainty sources of carbon accounts, another important topic. And of course, I'd share some practical side, data, open data, tools, emerging tools, platforms for carbon accounting. And of course, we'll end up with outlooks and synthesis. So, I'm relatively a new researcher slash scientist also. I've been publishing since 2021 mainly because of my PhD. So my research interests more on RS applications, also GIS. I've been GIS specialist also in the past, but now it's more on like RSAI application to to solve environmental problems in general. But I'm more particular in the application of EO, RS to ecosystem accounting, carbon accounting, and also I'm into digital agriculture, also smart, climate smart farming also to the Leeds Agri. And I founded a research NGO, Impact R&D, to also amplify the social impact of research, not just the scientific side. So let me just share some pictures of my phase 1 BSP engagement. So it's been, it was like last December, was my phase 1. It was a lot of lectures, workshops, and research. What I enjoyed the most was like sharing really my expertise especially to the students and young professionals. So very fortunate in that sense. Now it's also the last activity of my physical activity of my phase 2. So I'm happy to do it here. Yeah, so I'm expected also to publish papers after the engagement and stuff. But my BSP is helping also Reinvest Project 2, which Doc Isa will talk about later. Also, so my entry point are of course the geoinformation remote sensing requirement of the project. It's a natural capital accounting system accounting project in West Philippine Sea, so it makes me more interested in that sense. And I think we should really use environmental R&D to help strengthen our conviction that it's ours. Yeah, first some side pictures. So what we see, of course, are trees being cut, forest burning, forest being converted to most likely agriculture and also mining. And also in the coastal ecosystem side, so we see here. We see mangroves being cut for charcoal production. This is in San Vicente, Palawan. Mangroves being converted for fish pond land use, and also seagrass being degraded. So what also happens is that with these deforestation degradation activities, carbon and eventually carbon dioxide also is being emitted in the atmosphere. And of course, mind that CO2 is a greenhouse gas. So the GHG is being trapped, of course, in the atmosphere, and of course, it causes global warming. And this has also driven, arguably, the biggest environmental challenge of our generation, which is climate change. And of course, because of climate change, the world's ice are melting, sea level is increasing, typhoons getting stronger and also unpredictable, dry spell, and so on. So you've been experiencing it. I think also now it's a sign that this temperature increase also, this weather is also perhaps climate change driven. To help combat climate change, the ideal scenario is to, of course, to reduce the deforestation, hopefully degradation also, by protecting the existing forest. And of course, we should also plant more trees. We should also restore degraded forests. Of course, the younger the trees, the more carbon it sequesters. And it lessens, of course, the carbon in the atmosphere. So this role of the forest can be monitored and measured through AGB, or above ground biomass. So see, AGB is since carbon is half the weight of AGB. So in particular, AGB can be measured from above. It can be remotely sensed thanks to the satellites above, as you can see in the diagram also, and also in the from the field surveys. So in situ, and also so we have ground-based and space-based data sets requirements to map AGB. So above ground biomass and carbon, this should play. No, this should autoplay, but just imagine it's playing. uh, yeah, so the mapping of AGB before was primarily for timber production, for forest productivity estimates. But in the past few decades, it's well, the mapping rationale is that surveys itself can't do it alone. So we need to have like a practical approach how to have large area estimates, mapping and estimates also. Ever since, it's literally considered an essential climate variable, or ECV, which is of course a very crucial variable to understand the Earth systems and in its relation to the climate change. I hope we can still play it. One last try. Yeah, it's okay. So we can't continue talking about mapping without talking about remote sensing, or RS. So by definition, it's the acquisition of information of objects or phenomenon. So think about this object as a tree, or a phenomenon as a land use change from a distance. So you need a sensor, a camera, a special camera, a sensor that's mounted on aircrafts, UAVs, drones, satellites. So it's a signal-based interpretation of Earth's surface, depending on the reflected. You can see on the graph. Let me just check how if I can. Use the pen. Yeah. So reflected, and the energy, the light energy emitted from the surface. So yeah. So yeah, there are remote sensing windows. These white windows here, and the way sensors capture the emitted or reflected energy it depends on that window, and specific sensors can capture specific signals or energy. So we basically have optical sensors, and you're familiar with it. Of course, our camera phones operate on the visible window here. But we have like the invincible light. So special sensors capture that, and there's some unique characteristic of about that signal that our self camera phones can't detect. So we have, I can highlight, it's on my next slide, but I can give an overview now. Of course, there's these multispectral sensors. Yeah, there's thermal sensors, there's radar sensors also, and there is LiDAR sensor also. And the way the sensors capture it depend on the wavelength and the frequency of that. So by definition, you might hear about, you may probably heard about Earth observation already, so EO. So it's basically simply just satellite-based remote sensing. So it's more of the satellite taking pictures of the planet. So that's a European definition, because in Wikipedia you might see that ground-based observation of Earth also is considered EO, but take the European definition because of some. Uh, so EO, okay. So just to highlight also the sensors I've been talking about. So optical, you see on the left side, you see several bands. These are called remote sensing bands. We're familiar with the visible light, the RGB here, but as I said, there's like other more bands that can give us more information about the surface. Could be something about the health of the plant, the vegetation, something about the structure, something about the differentiation between land covers, and so on. So on the upper right, you can see some depiction of a radar sensor. So as I said earlier, it depends on the wavelength length. So those shorter ones can just simply detect the top of the canopy, like C-band, X-C-band. But some other longer wavelength sensors, radar, can penetrate the canopy and give us more interpretation of the forest. So these are like the biomass-friendly sensors, like L-band and C-band and P-band. And of course, there's LiDAR, which is like this nice picture color-coded, nice color gradient. So let me just, yeah, it's basically a point cloud out of point clouds from LiDAR's a laser as a sensor also. It gives us point clouds, and also at the end it gives us a forest structure indicator like height, and height we can derive biomass from height. Let me just, yeah, it's also called the ranging sensor. So you may common sensors, LiDAR sensors, of course, the ISAT2, built for measuring, sensing, mostly the boreal regions, and of course the GDI. GDI is like the more tropical forest-oriented satellite mission. So radar, of course, you might heard about Sentinel-1 already, ALOS Pulsar, and of course the optical ones are the most common, Landsat, Sentinel-2. Moving on, giving more context about how these different sensors distinguish land features. So that's the beauty of remote sensing signals, the way how we differentiate one thing to another. So in this case, it's like basically grass, soil, water, and also even forest types. So here we see coniferous and deciduous forest. And on the upper right graph, it's a backscatter from radar sensor. It's a backscatter signal that differentiates forest types also very clearly. And also on the upper and the lower right, you can see it can distinguish as detailed as forest species. So I'd like to emphasize also that we're in the RSEO golden era. So it's a lot of satellite missions being implemented, being operational. There's a bunch of satellite missions also dedicated to measure the forest in the coming years. So we have the biomass first P-band mission on space by ESA, not not ESA, but European Space Agency. And what's more interesting is that well, it's more of like the commercial side, but there's like satellites are getting smaller, and now there's this CubeSats that like a very tiny satellite that's flying around and dedicated to measuring specific things. So big EO data cubes, also like the new format now to for these remote sensing EO data sets. So you can see it on the this. So it's like more of like a time series EO data, differentiated, of course, spatially, temporally, also spectrally. So yeah. Okay, so AGB or carbon mapping based on remote sensing. Of course, it's in a way it's like easy to think. It's like RS signals. So you have the pixel value of remote sensing images, and the surveys and the in situ surveys you saw earlier. The plot biomass. So from as outputs of forest inventory, for instance. So we measure DBH, we measure the tree height, and then we estimate. We also measure wood density, and we estimate biomass from data using allometric models. So we relate the plot level biomass to the remote sensing signal, basically. And what we get, yeah. So this was yours truly, 10 years ago in San Vicente, Palawan. So the plot level biomass estimate is being related to the, well, when I say related, there's like a regression model, for instance, with the remote sensing data. And then we have like a regression model to predict biomass for each pixel after that. So it can also be like an exponential model in this case, where we relate plot level biomass to backscatter values. And yeah, so that also was my methodology when I mapped the above-ground biomass and of the Philippines using nonlinear regression model, machine learning based model. I use the NFI from DNR FMB and both optical and radar images, also to have like a nonlinear regression model that was able to map biomass at spatially explicit at nationwide scale. So, like given data availability, you can also like do an intermediate step, which is estimating biomass at local scales. When I say local scales, it could be 200 by 250 meters. Could be a bit bigger. So what drives it? There are airborne LiDAR surveys that are available, mostly in the topics. So given that, the plot level biomass is first related to the airborne LiDAR metrics. So we have a local estimate that's like really locally calibrated, and that's super important. And then that locally calibrated points are then related subsequently to the remote sensing data. So we have like a large scale map. So NFI, for instance, and then I should go ahead. NFI, for instance, and then local airborne LiDAR maps surveys. So we were able to map local scales, and then remote sensing data, and then we have a large scale, in this case, pan-tropical map. And that methodology was used by the benchmark biomass maps, Achi and Bassini maps. So. And then another methodology, it should play, but I think I should. Yeah, this one is the GDI biomass map from, of course, GDI spaceborne LiDAR. So it's only it's like in a it's like it came from the biomass was derived from height. So height was first derived from the point clouds and yeah it's the forest. uh, Water break.
Dither to 8 tracks, 600 meters apart, with 25 meters every 60 meters. That's 968 footprints per second. Laser energy traveling almost 300 million meters per second reflects off higher surfaces first, then lower surfaces shortly after. The tiny delay is detectable by JEDI's telescope sensor, which records the intensity of the reflection over time and uses the known speed of light with other variables to calculate.
Yeah, you can stop from that. Yeah, it's hello. Yeah, so GDI map is one of the most commonly used maps also from EO. EO is an EO product. So it also follows some rigorous sampling methodology in estimating biomass at pixel scale. So I should have posted the GDI paper link here, but yeah. Next, uh, medyo, a bit of technical assistance also with the notes. Sorry. Okay. Ah, kita yung notes ko. Okay, thank you. Okay. Mhm. Yeah. Parang nawala yung previous set. Next. Sorry. Yeah. Okay. Siguro one more note about the GDI map. So it treats the footprint as the in situ data. No? So um, yeah, and they have designed this sampling rigorous sampling framework to no, they implemented rigorous sampling framework to estimate biomass at pixel scale. So next is the CCI map produced by European Space Agency. So GDI was NASA and then ESA is CCI. CCI is yeah. So some maps can be estimated without the calibration data or the ground, the in situ data, the ground data. So it can be the pixel, the biomass value can be derived directly from the remote sensing pixel. In this case, some backscatter value of ALOS pulsar. And it's because of some ready-made physical equation already. It's been around for decades. So in this case, the authors have used the water cloud model to and fulfilled the parameter requirements to be able to map biomass at a hectare scale. So I was also involved in this paper. Uh, okay. Okay, so I've been talking about the above ground component. So might as well talk about the other components, the other carbon pools. So of course there's below ground, there's soil organic carbon, there's of course the deadwood and litter carbon pools. So mostly they're biomass dependent. So the above ground component dependent. So we mostly estimate these four carbon pools from the biomass using in the case of the BGC using root shoot ratio, which so for deadwood and litter, they use like the IPCC estimates, also suggestions that you apply some proportion based on some weather, climate characteristics, and also depends on the forest region that depends on the forest region. So I'm also working on a paper that tries to spatialize, so to create 5 carbon pools map out of EO datasets. So, yeah. And we also try to expand the study and do the carbon accounting using the two accounting frameworks. And then these are like, would like to share a preliminary finding, so don't post it. So yeah, it's basically the C-pools breakdown of from the 6 country cases, including Philippines, of course. Uh-huh. So what? So I'd like to highlight the relevance and applications of the C-pools map, not just the above ground component, but the C-pools map. So mainly it's used for the global scale application. Number one in the list is it's used as an input to the carbon models and climate models of to understand the Earth system more, project climate change better, etc. So I'd like to share also the survey we did 2 years ago, asking the climate modelers about the data requirements, and they were asking about we'll be happy if you give us time series biomass at least kilometers spatial scale. So yeah, most of them. Yeah. So before they were like just asking for a baseline map. Now they're asking for like really a time series. So of course it can be more dynamic, the model, and can have somehow integrate trends also in their projections. But second would be the IPCC guidelines for national GHG inventories. The document, as thick as this, it's published online also. And there's this tier 1 estimates, mean biomass estimates per distinct for forest strata. Forest strata defined by multiple factors also. But we're also trying to have EO-based estimates equivalent to the tier 1 estimates from using the GDA and the CCI. So it's an ongoing, it's a paper under review also. Collaboration with a bunch of international scientists. What's the relevance of this? That countries without data sets, without NFIs, for instance, relatively less developed countries can rely on these estimates for their national reporting. And of course, the global carbon budgets, the generic carbon report budgets that's being updated every year. So that also the biomap, global assessments also using biomass maps also matter in that case. And then there's these national applications, which is can also categorize this based on how countries report. So countries are mandated to report the UNFCCC, especially those who signed the Paris Agreement. So it's technically called as NDCs, nationally determined contribution of countries to track the commitment to reduce emissions from carbon emissions. And in this case, from the LULUCF sector. So there's also the RED Plus, or these reducing emissions from deforestation, degradation projects. Been around for almost a decade or so, and it's like more focused to these local, regional scale projects. So it's tied up also to the people on the ground that if they were able to restore the forest and manage it, they'll be incentivized. So that's the project. Okay, so later on I'll discuss the two big frameworks, the SIA and the UNFCCC, and perhaps compare them. But for now, let me talk a bit about ecosystem accounting, which is the synonymous mostly to SIA. It's an international statistical standard, last 2021, but it's been around for almost a decade already. It basically gives us a guideline how to implement carbon accounting, so as the nature, the ecosystem services will play a role also in the economic picture of the country. So its motto is making nature count. So what two main requirements are, of course, and also linked to each other. Of course, the physical accounts, which you can see in the upper part. Oh. And also the physical accounts can be made in the context of carbon accounting, can be provided by the biomass and carbon maps, for instance. The ecosystem service part can be also provided by dynamic carbon maps, or if you consider change maps, which I'll talk about later also, it can give an indication of the carbon sequestration of forests also, which is an ecosystem service. And then you have, like, on the lower part, the monetary accounts, where you apply some monetary valuation methods to quantify the ecosystem service. So in other words, it's like if you're rich in natural capital, ecosystem service, or also, of course, a wealthy country. And people will be happy, and the well-being will, prosperity will be assured. So that's the context. Okay. Yeah. So as I said, system accounting NCA is mostly complemented by remote sensing, earth observation, mainly because ecosystems are large spatial features. So you need to do the accounting per ecosystem, like mangroves, broadleaf forest, coniferous forest, and so on. So there's like a typology followed by UN, like the IUC and global typology in terms of the ecosystem classifications. So you do the accounting usually periodically, usually annually, but, every 5 years also possible. And yeah, there's also an ongoing community. The communities was organized 2 years ago, and now it's very active also. So the EO for EA community, and I was able to talk also last year with regards to this EO EA context. Okay, so this is also quite important, the accounting scales. So you do carbon accounting, of course, globally, as I mentioned earlier, in the global carbon budgets. So it's like a big table of carbon account, what goes in, what goes out, what's the net flux in the bio carbon pool. Yeah, and also an example of that is this table on the lower left, on the left side, disaggregated per ecoregion, and also per forest age, forest type, sorry. And of course, you can do carbon accounting, of course, nationally or subnationally. So I think it's also a clear requirement also of the carbon accounting frameworks that you do it at the national scale, subnational scale also. And of course, there's these ecosystem levels estimates, carbon accounting, which is imposed by SIA, of course. common spatial scale for SIA carbon accounting framework. So maybe I can talk a bit about the table. So in the lower right, you can see ecosystem types. So you see an opening forest hectare, the opening stocks, 2010, I think. And then you have like a column of the emissions. We were able to disaggregate emissions from deforestation and degradation in this case. We have sequestration column also, of course. And of course, when you subtract emissions and sequestration, you have net flux. If it's negative, it's bad. If it's positive, it's good. It's green. And then you have the closing forest hectares, so closing stocks. So okay. So the column over there on the right, that's the UNFCCC format. So it's mainly it's limited on the anthropogenic activities. Later on, I will also highlight the differences and similarities of the two frameworks. Okay, so going to the more on the small scale, local scale, regional scale carbon accounting. Yeah, so yeah, you can see this. Okay, so one example is of course the Red Plus program. So yeah, and an example map input for the Red Plus is the one playing in your screens right now. So in that case, we were able to map carbon emissions at high spatial and temporal resolutions, which is requirement of these local projects, Red Plus projects. And it also plays a role in the voluntary carbon market. These wherein carbon credits are, of course, there's a Lazada of carbon credits from these projects. And maybe you heard about the term carbon offsetting. So companies can buy these credits and also finance reforestation projects, for instance. So, and the way to monitor, report, and verify these kind of projects, of course, EO plays a big role. So in the transparency context. So, yeah. So an input to these, to be able to have inputs to the carbon accounting tables in terms of the changes, the fluxes, the emission, the sequestration. You need we need to talk about changes, fluxes of carbon. So seas change fluxes mapping. So in general, there are two approach. One is simply to difference two maps from two different periods. And you have a sea flux map at the end, which is exemplified by the map, the CCI map, and also the LVOD map. And you can also use a baseline biomass, like biomass year 2000. And then you can have an activity data. You have forest loss and gain maps also, or information with corresponding emissions and sequestration default. So like if it's a forest fire, this is the emission. If it's a conversion to slash and burn, this it's also forest fire. But if it's like agriculture conversion, this could be the emission. So it's being used. It's being updated like depending on the activity data that you have. So you can have you can imagine yearly carbon flux map and accounting table because of this approach. So yeah. Maybe I forgot. Yeah. Okay. So an example of a stack change approach. So you can stack change can also be differentiated whether it's a direct mapping or indirect mapping. So indirect mapping involves two maps that you subtract. And you can also directly map sea fluxes if you have the data. For instance, if you have remeasured research plot or remeasured NFI or remeasured local maps from airborne LiDAR. So if you have repeated measurements, you can simply you can already produce a biomass change from that, and you can already relate that biomass change to remote sensing data and have a seek flux map at the end. So here you see some examples of the 5 countries. Uh, so green means sequestration. You have net sequestration over the last decade. And so imagine the power of these maps. You can see hotspot maps where the emissions, where the sequestration. So so we chose to do it directly because there's some. It's known that when you do the indirect mapping, you subtract one map from another, the errors also sum up. So there's some statistical consideration also in that case. So I did some ensemble machine learning for this, meaning maps from different spatial predictions of different machine learning maps were harmonized to have a map, one map at the end. So that's like also the state of the art now. People are confused. Adrian's using random forest, and the other one is using SVM. One is contented with linear regression, and it's hard to assess them. So let me just make the average of them and have one map at the end. Okay, so this is like the big slide. UNFC, CC, and CF frameworks. So both are UN frameworks. Both measures ecosystem flows, like of course sequestration, emissions. Where did the carbon stocks go? Yeah, as I said, UNFC is limited to anthropogenic activities only. LULUCF, CS more EO dependent, I would say, and it follows like an ecosystem typology. But common thing about them, aside from the flows, is that both are not explicit about reported uncertainties. So if you see, normally the carbon accounting tables doesn't have like a plus minus okay, confidence interval, for instance. So that's also a big development now in the carbon accounting context. And I'll talk about it in the coming slides. So reporting carbon accounts uncertainties. What's commonly practiced is that I'm talking about the countries here who are participating to the RED Plus project of UNFCCC. So either they're not reporting the uncertainty, zero, no plus minus number, or they report the wrong uncertainty. So the estimation method has loopholes or needs improvement. Yeah, so first one is sadly practiced by most system accounting efforts also, and also, and well, some the RED Plus, because they've been around for decades already, the MRV system is more advanced, more mature. So what are they doing is that when the estimates of emissions and emission reductions and payments are reduced if uncertainties are high, assuming that the uncertainty estimates are robust or correct. So they also penalize the partners if they have, like, they're unsure about the carbon accounts. So say it like that. Or in other words, if the confidence interval, for instance, are really wide. Yeah. I should talk about the common map error, not only in biomass map, but in most environmental variables, which is like the signal saturation problem. So as you saw earlier also, the signal can only penetrate at certain wavelengths, cannot penetrate the canopy. So you see flat line there. You consider one forest and another, especially if they're contiguous, the same, because especially in high and very dense forests. And that results in map underestimation. So maps typically underestimate the high biomass part, So of course, that's the bulk of your biomass, your carbon. So you're already underestimating it. And that might be resolved by, like, of course, when you fly like a longer wavelength sensor like P-band, uh, the biomass mission, the LiDAR also mitigates that problem. Because of course, as you saw, that it can really have a nice waveform of the tree, structure of the tree. But these kind of problems, as we assess it, 4 maps, including the benchmark maps, suffer from this map underestimation. And we were able to say so because of the map assessment exercise that we did. So the independent validation that we did is also part of my PhD. So we have a global set of reference data. And we also were super uh, strict about the reference data side. We know for a fact that they are called ground truth, but they are not error-free. So you also should take that into consideration, estimate the uncertainties at the plot level, and after that, you can have a more meaningful comparison between plot and map estimates in validation context. So some errors can be from as early as the measurement stage. If the, say the, could be a human error, could be an equipment error, it could be from the allometric model. So that should be counted. Pixel size and also the plots can be have spatial mismatches, so they are not fit. They have usually plots are smaller, and they can be surveyed from different years also. There's also temporal mismatch, so and also geolocation. So there's a bunch of uncertainty sources, and you need to account that when you're doing validation to assess map accuracy. What we did also was to, given this information, we see an underestimation, and we have a global distribution of reference data. We were able to map the bias itself, the error itself, as a function of different environmental variables. So we got a map bias. We simply subtract it to the original map, and we have a bias-adjusted map after. So it's a function of tree cover, biomass itself, and also topography plays a role because these sensors like radar, of course, are topography sensitive also, and of course moisture also. But topography plays a role also. And if you want to read more, I can share the link also. Another important one is we really were. It's really common to see a lot of estimates from maps. A statistical estimate like a total or a mean or over large areas. And when you do that, you're technically doing a model-based approach, inference. Yeah. And it's when you do existence accounting, you cannot escape this uncertainty source. When you're doing spatial aggregation, you need to account for spatially correlated map errors because they don't cancel out when you aggregate. When you create a total, we can create a mean over the Philippines. What's the mean biomass? What's the total carbon? We need to account for that. And it's clearly shown in this diagram that weak spatial autocorrelation, you have narrower uncertainty, confidence interval, for instance, and with strong spatial correlation, there's so yeah. Okay, a few more slides. This is also important. Maps are products of samples of the, for instance, of an NFI, a research plot. You create a map out of that sample. It's also a sample. NFIs are usually sampled under probability distribution functions. So it could be stratified, an output of stratified, a sample of a stratified random sample, as sample from a random sample, a systematic one. So it's more of it's good if it's that if it's sampled like that. But if not, you can encounter problems also. That's what we call purposive sampling or ad hoc sample. So it most likely it will undersample, or it will misrepresent your study area, as exemplified by the red ones. So these are the areas in the features, environmental feature space, meaning um, that's what you underrepresent considering the forest variability and how forest strata are made, should be considered. So in other words, that's the red part should be the part that you should sample. And there are ways now to really assess it efficiently, conduct some representativity analysis. The first bullet one is more complicated. For instance, Philippines would want to have carbon account submitted next year to UNFCCC, and we will rely on the CCI map, for instance. So we should consider, because the first one, the previous slide was talking about uncertainty from residual or map error, autocorrelation, residual variability. And this one is from sampling variability, and it dominates the error budget at national scale and larger. So, but this nice publication highlights the need for map makers to produce this in their metadata, sampling covariance matrices, mainly because a sample can give you many kinds of maps or many variants, a multiverse of map. So yeah, that should really be communicated at least. So last few slides, forest area inconsistency. So you should also be cautious about this. There's a lot of forest definition. This one is from Estoque et al. Showing different forest cover in the Philippines. And this also from a study saying of differentiating forests reported from the different carbon accounting frameworks. And this also relates to my ongoing study with the INREM team. We're trying to compare 11 mangrove maps, so you can see it here. You can see immediately a large standard deviation here, 8,000 out of the 26,000 mean hectares. So that's something to think of when we try to choose or an ecosystem extent map for our accounting purposes. So this was like 8 global sources and 3 global sources, including the NAMRIA maps. Okay. Okay, let's talk about the local setting, Philippine setting. So let me share that ecosystem accounting was piloted 9 years ago to the Field Waves project, and I was fortunately involved in that project. From there on, several big projects also popped up, like this Cebol, the Reinvest 2, of course. And what's more interesting is the third bullet, which is the PENCAS is now officially a law, just a month ago, I think. So Philippine Ecosystem Natural Capital Accounting System Act has been passed. And then there's ongoing compilation, of course, of official EA accounts by respective institutions. I think there's also an ongoing NFI cycle, and of course our mapping agencies and will play a big role. Of course, we have PILSA already. If USA has NASA, we have PILSA. So. Okay. Enablers of RS-based carbon accounting. There's really a steep development progress in this context. You see map viewers, online map viewers that you can easily produce carbon accounts in few clicks. You have computing engines designated for these purposes, system accounting. One is like this OpenEarth monitor. So I'm also part of this project in my postdoc. So, and also this exercise that's trying to harmonize the global maps to create a better one. So this was the right part of the slide. You see like a map and some tables. So I'm playing around with the RR Shiny tool to quickly create carbon accounts out of EO maps. So there's a lot going on, a lot of things going on, a lot of developments, a lot of upcomings. Uh, this one is like we're preparing for the biomass mission next year. So yeah. So it's really more on like how to make these bunch of maps meaningful and, if possible, harmonize to serve a higher purpose. Um, Another important slide. I was talking about the upcoming missions. There are more. NASA will launch NISAR and L-band mission. There's Landsat next, which will increase spatial temporal resolution of the Landsat mission, 10 meters and 6-day repeated cycle, I think. And MAP mission, which is the hyperspectral satellite mission. So hyperspectral means we have more bands. We can see more, basically. We can see if plants are sick, or we can distinguish one species to another quite easily compared to multispectral. Countries are increasing its capacity to conduct NFIs and to produce their own reports also. So countries are also repeating their NFIs, so meaning we will have data sets for change, biomass carbon change. And I'd like to highlight also that the space-based and the ground-based can be integrated to produce a better estimate. So that's, I think, the state of the art now. It's not just map, it's not just NFIs, but the integration of the two really produces a better estimate or a better carbon account, for instance. And that has been highlighted by this study, which I was also fortunately involved. So what can we expect in the coming years? There's this 3-level carbon mapping, which is also a subject for debate in terms of usability and practicability and other things. There's TLS, of course. TLS has been around for decades now, but it's still very useful, and it's like really the most accurate option when we try to measure the forests on the ground compared to like the manual forest inventory. And there's this very interesting mobile laser scanner, and what's captured my attention the most also is this mobile app that can easily tell you us about the DBH in this case. So imagine if this can be operational, the inventory can be super fast. Okay. My last slide, and it's also I'm over time. I'm yeah, 10 minutes over time, I think. Just to wrap it up and also give you something to think also after this. So RS-based AGB carbon accounting, climate change context. So before it's mainly for production, for forestry, but now it's more encompassing environmental problem. I'd like to emphasize the second bullet, which is we should really think about uncertainties. It's easy to make a map, it's easy to make an AI model, but how sure are you, how reliable is that estimate from your model? You can simply report a high R squared, but is that true? Or is that a pseudo R squared? Or is your model overfitted? That's why it gives you a high R squared. So yeah. And map assessment, it's like a collaborative exercise. It also gives the map producers feedback. And it also leans toward harmonization exercises. So space-based and ground-based integration. One example was the bias reduction method I showed. There are other more things like more rigorous, statistically rigorous approaches. You can note about design-based estimates, inferences. You can note about model-assisted inferences, hybrid inferences, So this one I mostly showed you about model-based approaches because it's more of like an global setting with using a sample of non-probability based sample. So um, carbon accounting framework comparison. So UNFCCC versus SIA, and also the role of these online data repositories, computing platforms to speed up and also have more convenient MRV for especially for national and local projects. So yeah, thank you for listening and happy to discuss things with you. Okay.
Thank you so much, Dr. Arnan, for that informative and insightful discussion. I hope everyone appreciate the significance of this kind of very technical, but I hope everyone really appreciate these kinds of tools or frameworks. And if some of you are overwhelmed with the terms used during the presentations, I hope we learned the importance, especially of the mentioned multiple times the term AGB, or the above ground biomass estimations. That term, very technical, but I hope we appreciate that too, because that's very significant to better understand the carbon cycle, which us human are the main contributor of that carbon cycle, particularly in our vegetation or the forest land that we have here, for example, the Mount Makiling, which also help us in improving the efficiency of the forest policy and the management activities as well. So I hope our audience has questions ready as we move on to the open forum. Again, for our on-site participants, you may submit your questions to our speak. For our online viewers, you may also introduce yourself and post your questions on your streaming platforms. The comments or the chat box that we have here, and we will address them to our speakers. So do we have questions already on our online? For our on-site, you may raise your hand if you have questions. Before anything else, may we invite Dr. Arnan in the front? All right. So while waiting, let us prepare. You can request for a piece of paper for your questions for our on-site participants. All right. Let's wait for Dr. Arnan. But before anything else, I hope the discussion or the presentation of Dr. Arnan is very much you showed its importance or significance because of the word carbon. Although for me, it's honestly it's too overwhelmed because of the technical tools, the methodologies and frameworks that that have been discussed during the presentation. But yeah, carbon, because it is contained in all living things here in the earth. So its estimation and tracking is very significant, and I really much appreciate this kind of methodologies that has been used by Dr. Arnan and to our other researchers. So may we invite again Dr. Arnan in the front for our open forum. And for our on-site participants, you may raise your hands if you have questions. All right, so we have here our first questions from Mr. Ruben in Zoom. The question here is, all right, sir, you may sit in the front. And we have here, Dr. Arnan, our first question from Sir Ruben. The question is, can you please clarify what you meant with reporting the wrong uncertainty that you encountered in your study? In the study, how was it established so that the maps as products of in situ samples have acceptable uncertainty? Finally, can your carbon or vegetation mapping studies be potentially used to show species diversity correlation? That's it, sir.
So, baka ipa-ulit ko yung question, pero
The
yung
fir-
first question ay medyo tanda ko pa.
Yes, about
Yung
the
reported uncertainties and how they were able to say that it's like the wrong uncertainty. Parang the Red Plus project has a mechanism, as a protocol. They also have a pool of experts that assess the submissions. So, and they also have guidelines for the implementers, the participants of Red Plus, how to at least report the uncertainties and how to make it reproducible so they can also apply it, reproduce it in essence. And of course, I'm sure they have statisticians that can say whether it's like optimistically or pessimistically estimated or realistically. And I'd like to also highlight that uncertainties can also be validated. So in the university, there's like now that they're like push also that uncertainties reported finish. No, there should also be another step for that, which is to validate the uncertainties, and that means that you need more samples to do that. So, but generally, these kind of initiatives, they have stipulations. They have strict stipulations about the uncertainty values. It should like be, you can imagine like it should not exceed 20% of the RMSE, for instance, or I'm just saying examples. And the error shouldn't exceed this much. So there's like strict stipulations about the uncertainties also. And I got the third question, which is about the species diversity. Definitely, that's super important when when we have like spatially explicit map. It can have spatially explicit estimates also of the forest, meaning one pixel, the other neighboring can be differentiated. Unlike with other estimation methods that you have a land cover, you have a mean biomass that you apply to that land cover, and then you have one value for one contiguous area without spatial variability of biomass and carbon. So that's the advantage of the pixel-based approach, the remote sensing-based approach. You can capture this variability also from one species to another. Also, if you can overlay a species map of your own, you can have that. And that species map, that could be another product. Which can be derived if you use more like advanced sensors like hyperspectral sensor, or even drones, for instance. So, yeah.
The second question is about the maps as products of in situ samples. Does it have acceptable uncertainty?
Yeah. So there's like I forgot to say about the CEO's Community of Earth Observation validation protocol. So all the stipulations about map accuracy and also the accepted accuracy level of maps are stipulated there. But there's also, I'd like to emphasize also that the requirements depend also on the user. So the climate modelers are specific about these kind of requirements, and the national users are specific about the requirements. So in general, they have like a generic map accuracy requirement, but that doesn't end there. We really need this independent validation exercise to really tell that, to really be sure about that. And when I say independent, like you need to use a reference data set that hasn't been used in the map production pipeline, and ideally by like a community that wasn't involved in the map, but that's like more secondary. The primary one is like requirement that you should use a reference data, a ground truth data that to assess map accuracy that hasn't been used in the map calibration process.
In relation to that first question, sir, there is a second question. If there is an established guidelines already in estimating that uncertainties, and what are the major sources of uncertainties that it needs to be accounted?
That's a good question. There's like an uncertainty estimation section at the CS Calval protocol. It's the main author is Duncan. If you can like browse it now, the main author is Laura Duncanson. Uh, it's also well written, well categorized that at the even at the plot level, what should be accounted, what should be estimated, and I somehow enumerated that in my presentation that you should account for like the major ones in my view, and also based on our papers that the measurement error at the plot level. When you choose the wrong allometric model, it gives you problems there. When you use a very small plot and you compare it with a large a map with a large pixel, spatial mismatch is high, so that so within pixel, we call it sampling or within pixel uncertainty. Um, ano pa nga ba yung
Is there an established guidelines in estimating that
yeah,
uncertainties?
there's mature how-to methodology in that. It boils down to error propagation methods, mostly analytical, mostly Monte Carlo based. But the assumptions that you need to have like a, for instance, an allometric model. You need to have a probability distribution function of the parameters also of that model, and you need basically it's like a statistical error propagation method when you would want to estimate, in this case, plot level uncertainty. But in terms of the map, yeah, that's another thing. It's like the usual ones are like it's like input level, how the input, the intermediate products of that map sums up in terms of the error, the uncertainties. But the more alarming one is when you try to derive an estimate out of the map, and that was like the uncertainty from residual variability and uncertainty from sampling uncertainty variability. So those two, and that's an ongoing research, I think, especially the latter, the sampling, and the map makers really play a role in that. But yeah.
In terms of the remote sensing that you've been using in your study, the question from Hannah Alexis is that remote sensing can be used for sediment carbon accounting?
Ooh. um, inom muna ako. um, the soil can be remotely sensed, as I said also. And then, but in terms of how much of the soil becomes sediment, you need a tailored designated modeling software for that. So that requires like soil erosion, runoff, soil properties inputs. So maybe in the soil property part, yeah, that remote sensing input can be used. Yeah.
With all the methods that you use in your studies and the tools, is there also a standard method for the AGB or the above ground biomass accounting here, specifically in the Philippines?
Another good one. We have reliable allometric models around. Like as far as I can recall, there's the Rebilia allometric equation and a bunch more other ones. And I think at FMB has already 2 NFIs because I was able to use it, so I know. So I initiated the national map of Pabgan biomass because I was able to secure the NFI also for research purposes. So that's why I coordinated with FMB and I tried to generate this national map. But definitely there should be like the official government produce maps like this, biomass and carbon. And sooner or later there'll be published ones, or I think there's already ongoing initiatives to like make an official AGB map of, and crucial to that would be of course the NFIs, and we also might know that we also have the LiDAR, nationwide LiDAR data, so that could also play a role. Mhm.
Let's move forward to other topics that you have presented, Dr. Arnan. And there is a question from Mr. Asmitoso about the difference in species composition accounted for in carbon sequestration estimates. How is the difference of that given that different species sequester carbon have at varying rates?
Another good question. That should be really considered when we go to we zoom into to local regional local scales, how the space variability plays a role. If there's data availability and there's like that should really be considered, uh, and better if you really have like a species level map to really account for that, the species or taxonomic variability in terms of sequestration. But it's more of like a factor of age also. So forest age, trees sequester differently when they're more when they're young, and I think another key consideration is forest age. Yeah.
All right, sir. Thank you for that. Another question, sir, from Mr. Carl Villegas of the UPOU FMDS. He asked about if there is already an intervention that takes into account the effectivity of landscape scale restoration areas in various country. One of these is the NGP as carbon sinks, considering the various typologies that we have.
Definitely. So, uh, remember my last slide about the emerging technologies, the online platforms, the open data sets. I think nationally funded projects like NGP should we should be able to view at least or monitor the progress of them to these mediums. There's a bunch of studies already around us already assessing the progress of such restoration projects. But I would say that really remote sensing will play, if not the main role, the key role to this, because you can track the historical information of the landscape before, during, and after the NGP, and you can see trends of the signal, whether it's going down or going up, some greenness indicator or some structural index like height, or of course biomass carbon itself. So if you do it a time series approach, you can see trends, and you can compare you can also distinguish between a restoration project to those naturally growing forests to see some distinctions also. Definitely, the bunch of time series data, the richness of EO data can be used for these purposes to assess.
All right. Maybe we have question on site.
Good morning, Sir Arnan.
Good morning, Adrian.
Sir, since you mentioned the SEA framework that is mainly used for natural capital accounting, I would like to get your insights on the utilization of different open source data sets, especially on the delineation of physical extent, given that SEA mentioned the use of IUCN global typology, and of course the availability of our local data set by NAMRIA, and also the state-of-the-art platform in mapping ecosystems.
So about the classification, of course, the use of open data set and the classification that at stake when we try to do the SEA-based accounting. So I would say that the typology that SEA is following has some level of classification. And the accounting system, we can decide whether we want the level 1, which is more this generic, and we want to go level 2 or 3, which is like the more disaggregated. And it's like there's discretion about that. I mean, there's subjectivity about that. And I think the open data definitely fit into the level 1 generic classification, especially even our local data sets. So Um, and if we would want to go deeper, we may need to request for a reclassified version from the official source, or we do the mapping ourselves. So, yeah. So, but it's nice to think about that at this point, because definitely we want to go uh, at the higher level of classification along the way.
Okay, sir. And then my next question is related on the study conducted on the, I think, two of the sub-watersheds of MFR. And then concerning on the estimation of total above ground biomass per species, and it is derived from Brown's equation. What are your insights between using total above ground biomass values based on these allometric equations and on the use of remote sensing-based estimation of TAGB?
So you mean the Brown based equation is used to produce the plot level estimates, right?
Yeah.
And that plot level estimate is used to map or
Yes, sir. And then they quantify
Oh, yeah.
the value of TAGB
Yeah, I mean,
per
the-
family po pala.
definitely there's some very good reason for that. Might be that the Brown is locally calibrated, so it is like suitable for that area, and it is also the good practice, especially in these local study local areas. So you use a suitable allometric equation that has been calibrated perhaps in this area or similar from a similar area. So I think that I'm not sure, but I think that that's justification. Yeah.
Thank you, sir.
Thank you, sir. All right, for our online participants, we have questions here about the Global Forest Watch. So from Miss Ruth, her question is about, do you happen to know a specific technology that uses Global Forest Watch? And are there data within that accepted uncertainties? And if there is data, are there data generally within the accepted or the acceptable values?
Yeah, I'm really not sure how. I can't make an example, but I can say that Global Forest Watch has been really like the go-to platform, especially for less developed countries who don't have the resources to make their own. And in fact, in fairness due to WRI, which is the implementer of GFW, they're very active in engaging with countries in this context. In fact, they have like a small grants initiative that researchers especially from less developed countries, can propose their some projects using Global Forest Watch for forest monitoring, conservation management, also for carbon accounting. Um, uh, for sure, in the coming years, we will see one. Yeah, I
How
think.
about here in the Philippines, sir?
Well, I know specific municipalities that have been using Global Forest Watch. And if you're watching, my friend from Nara, Palawan, Menro Neil, he's the example. Yeah, and a bunch of, definitely, and also for research purposes, I've read several papers that have used Global Forest Watch, the data from GFW to have these assessments, forest monitoring studies assessments.
All right. So for our last question from Mr. Alan Villanueva, from Mr. Chris Oka, are you familiar with eddy covariance system? Do we have a plan to install one in a forest here in the Philippines?
Yeah, these flux towers. So it's mostly for measurement of the carbon fluxes in general. That would be nice, and especially in focus areas where it should be installed. And I think it's also about time. If I'm not mistaken, because I saw like a maps of the flux towers globally, and I haven't seen one. I'm not sure, but there's like less flux towers in the Southeast Asian part. So might as well consider that. And I mean, that's also something to suggest for the respective institutions.
Eddy covariant system. All right. Maybe we will accommodate one last question again from Mr. Alan Villanueva. So we will go back to his question about can the tools already be used to monitor carbon sequestration in areas with thick forest vegetation in the country, and are the data generated acceptable to transact in the carbon market?
Yeah, it's a good one. I mean, it depends on the spatial resolution in that case. Can I read it?
Can, here, sir. Can the tools already be used to monitor carbon sequestration in areas with thick forest vegetation in the country? And are the data generated acceptable to transact in the carbon market?
Um, for, well, carbon sequestration is like you really need time, at least multi-date maps to measure them. And I think tools, if you're mentioning about Global Forest Watch in this case, definitely they have like a bunch of sequestration maps in their platform. And
About the
yeah,
generated.
so for sure, these kind of platforms, it's common to have like metadata of the maps that they're displaying, and not just metadata, but also access link to the maps. So I think included there is like the reported accuracy of the EO product maps, and if you're unsure about that, I mean. It's also a good practice to conduct a map assessment on your own, a validation on your own, especially if you're using it for a local purpose or regional purpose, specific purpose, like in this case, this carbon markets. I think the crucial part there is that aside from the visualization, of course, the accuracy and the uncertainties of, say, the emissions and sequestrations of the restoration site, for instance. So definitely those information should be there in these kinds of tools platforms.
All right. One last questions, all right, for our on-site participants. You may ask, sir.
Hello, Sir Arnan, and congratulations. Milben Braga is from FMDS. So first of all, congratulations and thank you for your initiatives, no, pagdating sa ating inventory remote sensing and national forest inventories. So based on your global perspective, comparing dun sa ibang mga nations, so ano po yung status ng ating skills, no? So nandyan ka na, and then we have also NAMRIA, FMB, PhilSA, no? So ano po yung status nating Philippines pagdating sa carbon accounting? And yung last question po siguro para dun sa mga students and mga enthusiasts, no? So ano po yung advice natin or napagpukosa natin para medyo mas gumaling tayo pagdating dun sa remote sensing and GIS. No? Thank you po.
Thanks, Mix Milben. Ano, very, ano yun, two very good points. Ano. Well, we're not lagging behind. I mean, compared like decades ago, now there's been a leap ano, in terms of capacity. Ano. So, for the longest time, we've been relying to a certain institution, but now we have our own Philippine Space Agency. So that's like a major one. And I think we've been also sending scholars also around to study abroad. So that's nice. And there's also, of course, the Balik Scientist program like this to have this certain expertise echoed and shared in the home country. And as far as I can recall, because some colleagues also conducted, compared the country capacities in terms of remote sensing and NFI. Actually, we're not behind. Actually, let me just quickly recall. Let me say that there's still several countries that not as capacitated as us. So let's say it that way. Yeah, and in terms of the advice, I would say don't get blinded by the technology, by the hype of the technology. Like you try to understand it your own. Like I'm talking about AI, and I'm talking about like the shortcuts. I'm talking about talk about shortcuts because now remote sensing, most of the available data analysis ready already. So they skip the nitty gritty pre-processing, which also allowed us to, which also important because you know how um, uh, what was your map before it became a map. So and it also in my case it also gave me some skills like the some physics back context, some pre-processing and a bunch of other pre-processing um, knowledge and skills. So I think, yeah, I think before using also a certain map, certain EO product, that in this case, you should really think whether that map is useful, and you should also be aware of what to look at, and also just look at the metadata also, and also and investigate on your own, assess the map on your own. So that's more of like the mapping using the EO product side. I think more in general, like uh, I won't say that the usual follow your heart, follow your passion, etc. But if there are opportunities also to explore and to learn more and to get out of your comfort zone, do it. It's uncomfortable, but great things happen when you do that. So I would end with that, and hopefully that's
Yes.
the last question.
Yes, sir. Thank you, sir, Arnan. And that's it for our open forum. We are thrilled by this thought-provoking questions that continue to pour in. However, due to time constraints, we'll need to wrap up the open forum. Thank you so much, Dr. Arnan, and thank you everyone for your active participations. With that discussions, I hope um, we learned that this kind of discussion should help us not only to communicate this kind of topic, but let us find ways to support this kind of forest carbon cycle tracking or tracking systems that we use to um, support them in operationalizing this kind of tools. All right. So, of course, we would also like to express our thanks to our speaker. So now may I call on Dean Joanne V. Serrano and Dr. Maripres U. Sarinas to award the certificate and token of appreciation to our speaker. And allow me to read the citation. The University of the Philippines Open University Faculty of Management and Development Studies presents this certificate of appreciation to Dr. Arnon B. Araza for serving as the speaker during the Let's Talk It Over series Usapang Mapa at Kapaligiran, a discussion series on urban planning, environmental management, and sustainability, Episode 1, Forest Carbon Accounting Using Remote Sensing, held on 22 August 2024 at the Audiovisual Room, UP Open University. Given this 22nd day of August 2024 at UP Open University. And once again, let us all give a warm round of applause to our speaker. Also, thank you very much, Dr. Joanne and Dr. Serinas. And to formally close the program, let me call on the representative of the chair of UPLB INREM. Dr. Isa Jose Usahise is professor at the Department of Economics, College of Economics and Management, UPLB. His fields of interest include natural resource and environmental economics, bioeconomic modeling, environmental valuation, applied econometrics, impact evaluation. He obtained his Bachelor of Science in Economics from the UPLB and his degrees in Master of Science and PhD in Agricultural and Resource Economics were both obtained from the University of California, Berkeley. He also one of the project leaders for the Reinvest WPS Project 2, and here to deliver today's closing remarks, Dr. Isa Jose U. Sahise.
So magandang umaga po sa ating lahat. Dean Serrano, Ate Maripres, Gandang umaga po. So we have come to the end of this very informative seminar on forest carbon accounting and remote sensing. And on behalf of the chair of INREM, Dr. John Pulhin, I would like to extend my sincere gratitude to all of you on site and online for your active participation and the insightful questions. The seminar has provided a valuable platform for knowledge sharing and, more importantly, the first collaboration between, and hopefully the start of many more, between INREM and the Faculty of Management and Development Studies. The presentations and discussions have highlighted the critical role of forest carbon accounting and remote sensing in addressing a very pressing issue, which is climate change, and also promoting sustainable development. I am particularly grateful to Dr. Arnan, for his invaluable expertise and insight. The Reinvest Project 2, this is our second hosting of Dr. Arnan under DOST Balik Scientist program. So let me just talk quickly about Reinvest Project 2 kasi sabi ni Arnan, I will talk about it daw. So the project basically aims to establish yung ecosystem services accounts for marine and coastal ecosystems in the West Philippine Sea. So although the project started before the PENCAS law, it is nonetheless envisioned to support the implementation of that law. These accounts will help us incorporate seamlessly the value of and the benefits of preserving our ecosystems into economic planning. Sabi nga nila, you cannot manage what you cannot measure. These accounts, as I've said, will be linked with the country's economic accounts. So ang mangyayari dyan is when you plan for economic growth, you do it in consonance with the preservation and conservation of your ecosystems. So pag na-establish na yung accounts and it's linked with the economic accounts, will be the days that after planning for the economy, the environment becomes an afterthought. Okay? So we established the accounts for the West Philippine Sea muna because of the urgency of the situation in the West Philippine Sea. We are losing ecosystems at a very fast rate because both of internal, LTIO, and external forces. So the vision is to extend to other coastal and marine ecosystems what we will develop dito sa West Philippine Sea. And this endeavor is inherently spatial in nature, and that's where Doc Arnan comes in. And that is where he has been very helpful. So despite yung maiikli or very short engagement ni Doc Arnan with the Reinvest Project 2 under the Balik Scientist program, nonetheless, he never failed to amaze us how he can do so much in such a short time. So in particular, yung kanyang dedication to train yung supposedly young researchers namin doon sa aming project in particular. So I think that's really shows yung commitment niya to pay forward or bring back to the institution that has nurtured him, the field that he loves, and of course yung Philippines. Yung contributions niya have enriched our understanding of the latest advancements in the field, in particular yung Earth observation, and probably has inspired at least Adrian to explore new avenues of research and applications. As we move forward, let us continue to harness the power of technology and innovation to advance our understanding of forest ecosystems, yung contribution niya to our welfare, and their role in mitigating climate change. By working together, FMDS, we can make a significant contribution to building a more sustainable and resilient future for our planet. So once again, on behalf of Dr. Pulhin, the chair of INREM, marami pong salamat for including us in this activity, and mabuhay po tayong lahat. Salamat po.
Thank you so much, Dr. Sahise. And that concludes our program. Before we leave, may I request everyone to answer our short evaluation form, which you can access through the QR code and link flash on the screen. We would appreciate your feedback on how today's event transpired, and you will receive an e-cert only after completing the evaluation form. Please wait for 5 to 10 business days before you receive the certificate. And on behalf of the FMDS, we thank all of you who joined us live and virtually today. Riza Ana Alforja, and this has been the FMDS UPOU and UPLB INREM for the LTIO series Usapang Mapa at Kapaligiran Episode 1, Forest Carbon Accounting Using Remote Sensing. Please stay tuned on our social media pages for the next 2 episodes for the series, at maraming salamat po. May I invite everyone via Zoom and those present here with us at the AVR for a photo opportunity. Zoom participants, may we request to open your cameras. Thank you po.